Welcome student, welcome to Poor Academy. I am Ashish. Today our topic is conditional probability part 1. I have already made a video on conditional probability part 1, which is the introductory to conditional probability, where some concepts which are required for learning conditional probability are given. You must learn part 1 first, then part 2, and after part 2 you must view the part 2 and part 3 video to be master on the conditional probability topic. So let's start without wasting time. Start on the some good example, the concept on the conditional probability. Now first problem, let us discuss conditional probability with the help of an example. Then you will understand difference between ordinary probability and conditional probability. So two coins are tossed. This is a very simple example. Two coins are tossed. What is the probability of getting at least one head? This is ordinary case. We have learnt in class 11. And this part, at least one head, same like this. Given that the first coin shows tail. So this is from B, you will see conditional probability. So first A, so what are the outcomes if two coins are tossed? This is sample space. Sample space is two coins are tossed, the outcomes are head head, head tail, tail head and tail tail. So there are now total number of NS equal to 4, 1, 2, 3, 4 sample space, and let A is the event of getting of at least one head, and the what are the its element? At least one head, that means two head also satisfy. So at least one head, so head head, head tail, tail head. These are the elements, and NA is 3. NA is equal to 3. And what is the problem? Ordinary case. What is the probability of getting at least one head? So probability of getting at least one head, probability of 8 is equal to total number of favorable cases. These three elements, so NA, total number of favorable cases divided by NS. That means 3 by 4 is the ordinary case, is the probability of getting at least one head. At least one head. So 3 by 4 is the answer. Now B, at least one head, given that the first coin shows tail. So you have given additional information. In conditional probability, you will be given an additional information, given that first coin shows tail. So first coin shows tail. So in the same like ordinary case, there are one event of getting at least one head. This, and B, we have to assume another event. When first coin shows tail, B is equal to event of first coin showing tail. So there are two events, A and B. A is the event of get at least one head like this, and there is another event, the first coin show tail. So event B has already occurred. This is conditional probability. What is the condition? The condition is B event has already occurred, then tell what is the probability of A. In the first case, we are simply asked what is the probability of A. There is no condition, that is, it is an unconditional probability. Now, it is asked what is the probability of A, same, but one condition. What is that? That another event B, that first coin shows tail, that first coin shows tail, then what is the probability of getting at least one head? That means B event has already occurred. So we denote this conditional probability as probability of A when B has occurred. That means probability of A when B has occurred. This is just a symbolic. It does not mean A divided by B. No. Just it is symbolic that B has occurred. What is the probability of A given that B has occurred? So see what we are given additional information. This is sample space and this is A, and now the first event B event would be the first coin shows tail. So first coin shows tail, this no, this first call head no, this first coin shows tail. So tail, head, first coin shows tail, tail, tail. These are the two elements of the two outcomes of the event B. Now it is said that B event has occurred. That means TT has occurred. So what is the probability of get least one head? So our choice is not limited to this, but our choice is limited to the intersection of this and this. Because first coin shows tail, and then what is the probability of getting at least one head? So this element satisfy both A and B. That event B has occurred, first coin shows tail, and event of getting at least one head. So there is one head, at least one head, so satisfy. So TH is the only element which satisfy both A and B. So in case of conditional probability, first our target would be to calculate intersection of A and B, common. What B has occurred, so what is the intersection of A and B? That means number of element of A intersection B. So what are the number of A intersection B? A intersection B A intersection B is only, you see, this is A and this is B. A intersection B is only TH. So number of element of A intersection B is one element. So you are clear, the numerator would be, if B has happened, the intersection or A and B, because the B event has already occurred. First element, first coin shows tail, and what is the probability of getting at least one head? So this is the only favorable outcome. So we are interested in calculating A intersection of A and B and its number. So and the numerator you have calculated, but denominator would be not entire sample space, but the sample space here is reduced. Sample space is reduced. The event which has already occurred, that would be the sample space for conditional probability. Here B has occurred. What is the number of elements of set B? Number of set of B is 2. So not 4. 4 is the total number of element of the sample space S. But here denominator would be the number of element of the event which has already occurred. that is B. So what is the number of elements of set event B? It is 2 elements. So here we denominator will be number of elements of set B, because B has occurred. You see the difference between these two. Here sample space, number of element of the sample space. Here number of element which of the event which has already occurred, that number. Here total number of event favorable. Here intersection of A and B, number of element of the intersection. So intersection we get 1 element, and here total number of element of set B is 2. So probability is half. So this is half and this is 3/4. These are the two difference. I have kept both the type of problems side by side so that you can understand. The ordinary probability is 3/4, but the probability of A, here is already also probability of A, but it is unconditional. Now probability of A when B has occurred. How will you calculate? First we are interested in calculating intersection of A and B, and how many elements? 1. And then which element has occurred? B has occurred. Number of element of B. So clear half. Now I am telling you something extra. So if I draw a Venn diagram, and elements A and B sets, so what is the probability of A when B has occurred? So we are taking first number of element of A intersection B, that means this part, as numerator, and divided by which has already occurred, that means B has occurred, to number of elements of B. So number of elements of B, that means this portion, entire this here, number of elements of B. And if it is called probability of B when A has occurred, probability of B when A has occurred. Now what is the probability of A when B has occurred? Conditional probability of A when B has occurred, number of elements of A intersection B divided by number of elements of B, because B set a B event has occurred. Now I may change this formula. You may use this formula, or if I divide both numerator and denominator by number of element of sample space, here NB divided by number of element of sample space. So both numerator and denominator are divided by number of element of the sample space. This you will get what this portion is, number of elements of A intersection B divided number of element of the sample space. That means this is the probability of A intersection B, and divided by number of elements of set B divided by number of elements of the sample space. This is probability of B. So either you use this formula, n number of elements of A intersection B and divided by number of element of B, or probability of A intersection B divided by probability of B, dividing both numerator denominator number of element of the sample space. So the probability, so the conditional probability of A given that B has occurred equal to probability symbolically, probability A given B equal to N A intersection B divided by N B, or probability of A intersection B divided by probability of B. You can use this formula or this formula as you deem fit or easy. Both are will have the give same result. So this is conditional probability. First we have to see which has set as occurred. The number of element or its probability will come as denominator, and numerator will be number of element or probability of A intersection B. This you have to remember. Okay, because sample space is reduced, not we are taking entire sample space, but the elements, number of elements or probability which has already occurred. If B occurred, then take the element, number of element of B or probability of B. Clear? Then we will get conditional probability. Let us take another example. This is a very good problem. This is a mainly NCRT problem, and it was slightly modified. Example 2, 3 coins are tossed. If 3 coins are tossed, the total number of outcome would be 2 into 2 into 3, that means 2 into 2 into 2, that means 8. And I have listed these 8 outcomes by making a tree. So you will get HH, head, tail, head, like this. 8. There are possible outcome. I have listed in a sample space all the 8 elements. So 3 coins are tossed. What is the probability of getting at least 2 head? We are interested in at least 2 heads. The head number of head must be either 2 or 3. So I have taken let A is the event at least 2 heads. Now what is the sample space? There are 8 ways, there are 8 outcomes I have listed. So number of outcome of S is 8. Total 8 elements of sample space. And at least 2 heads. You see, these are the at least 2 heads, at least 2, HHH, HHT, HHT, HTH, HTH and THH. These 4 are the favorable supports which satisfy event at least 2 heads. So number of element of NA equal to 4. Now the first is the ordinary case, and second is conditional probability. It is ordinary probability. What is the probability of getting at least 2 heads? So at least 2 heads, their number of element is 4 and sample space 8. So what is the probability? I am writing here. What is the probability of getting at least 1 head? So probability of A, ordinary case, equal to total number of cases favorable NA and total number of cases NS, equal to total number of favorable at least 2 heads 4, total number of case 8. That is half is the probability of getting at least 2 head. This is ordinary case. But we are mainly interested in B. What is the probability of getting at least 2 head? Same as A. Given that is the condition, given that first coin shows tail. So first coin shows tail, it may be another event B. So let B is the event, first coin event, first coin show tail, first coin shows tail. So this event, the elements of this event, first coin shows tail. So first coin shows tail, shows this one, this one, this one and this one. So tail, head, head, tail, head, tail, 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 head, tail, tail, tail. So number of element of B event 1, 2, 3, 4, also 4. Now what is the probability of getting at least 2 head, that is probability of A, given that the first coin shows tail, given that B has occurred. So it means how we calculate A intersection B. So what is A intersection B? A intersection B, A intersection B equal to A intersection B, HHH no, HHT, HHT, HH, HHT, this is THT, HHT no, HTH, HTH, HTH no, TTH, sorry, HHT, HTH no, THH, 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 to THH, this and this. So only common elements is THH. So THH. You see, it satisfies both. The first coin shows tail, okay, and at least 2 head. At least there are 2 heads. So this satisfies. So number of element of A intersection B is equal to 1. So this is equal to number of element of A intersection B divided by and the denominator will be not the sample space but the elements which has occurred, event occurred, set B. Elements of number of elements of set B is 4 equal to 1 by 4. 1 by 4 is the answer. Or you can calculate it by another method. We have told you probability of A when B has occurred equal to probability of A intersection B divided by probability of B. This is also formula. Either N A intersection B or NB divided by probability of A intersection B by probability of B. So I can also calculate this. This equal to probability of A when B has occurred equal to probability of A intersection B by probability of B. So what is the probability of A intersection B? Probability of A intersection B equal to total number of cases A intersection B 1. So its probability was 1 by 8. It was probability of A intersection B whole divided by probability of B. So B number of elements 4 and the probability of B total number of cases is 8. That means 1 by 8 into 8 by 4. So ultimately 1 by 4 is the answer. So ultimately there are both ways. Either you can take number of elements of intersection B or probability of intersection B and denominator number of element of B or probability of B. Both probability, because the same thing is divided 8 divided by 8. If number of elements is divided by number of elements of sample space, it becomes probability. and it is also divided number of elements of sample space, it becomes probability of B. Clear? This is a very good problem of conditional probability. A family has two children. Okay, there are two children, maybe boys or girls. What is the probability that both are boys? What is the probability that both are boys, given that first one is a boy? This is a problem. Either A or and B is separate problem. What is the condition given? The first one is given, that it is a boy. And what is the possibility, what is the probability that both are boys, given the condition that first one is a boy? I am not considering B part. First I am solving first part. A family has two children. What is the probability of both are boys, given that first one is a boy? First one is boy. So let us draw the sample space. Sample space, if they have two children, they may be both boys, second one boys, boys, girl, boys, and girl. So number of element ns equal to 4, 1, 2, 3, 4. So A event, considering I am A event, is the event A is the event of two boys, and B is the event that first one is a boy. Event that first one is a boy. Now, what is the number of elements? Event two boys. Two boys, there is only one possibility. Both are BB. Both are boys. So NA equal to 1. The event that first one is a boy. First one is a boy. So what are the elements? First one is boy. First one is boy. First one is boy. Here first one is girl. First one is girl. No. So these two are to be considered. Even the first one is boy. So BB and BG. So number of element of B is equal to 2. Now you are asked, what is the probability that both are boys? That means probability of A. So probability of A, given that the first one is a boy, equal to, what I will do? Intersection of A and B, because which will satisfy both. First one is a boy, first one is a boy, and the both are boys. So the intersection of A and B, you see A, this A and B, intersection same BB. So intersection of A intersection B, and given set number of element of N B. Set would be which event has occurred and its number of element of that set, not the entire sample space. Sample, I am repeating again and again. Sample space is reduced, not entire 4. It is reduced to number of elements of B, because B event has occurred. So B number of element of set B. Or you can apply probability of A intersection B divided by probability of B. So let's first try this method. Number of element of A intersection B. A intersection B. A, this one A, this one B. What is the intersection? BB. BB. And number of element then 1 common BB. So this is 1 whole divided number of elements of B. So number of elements of set B is 2, is equal to 2. Okay, and if you take this formula, probability of A intersection B, what is the probability of A intersection B? 1 is the number of A divided by sample space number 4. So 1 by 4. 1 is the intersection and its probability is divided by number of elements of the sample space. And here the whole divided by probability of B. Probability of B is 2 out of 4. 2 by 4. So this is equal to 1 by 4 into 4 by 2. So is equal to 1 by 2. So first condition I have given. First one is a boy. What is the probability that both are boys is half. Clear? Now we'll apply the second condition given that there is at least one boy. So this portion is same, A is also same, but we will now consider another condition that at least one there is at least one boy. So let's see is the event at least one boy. So what are its elements? At least one boy, BB, at least one or two, BB, BG, GB. GG, no, both are girls, no boys. So at least one boy, so number of elements is NC. NC is equal to 3. Clear? And now it is asked, what is the probability that both are boys? That means probability of A. Probability of A, given that there is at least one boy, that given C. So this is equal to probability of N in A intersection C whole divided by C has happened given, so number of element of C. So number of A intersection C you see BB, one common BB. So number of element equal to 1 and number of element of C 1, 2, 3. 3 is the 1/3 is the answer. Or if you take probability of A intersection C divided by probability of C, will get 1 by 4 divided by 3 by 4. That means 1 by 4 into 4 by 3 equal to 1/3. Clear? Clear, I think. You remember when A intersection B or say anything, you have first take intersection, either number of element or probability, and then which has happened is denoted by stroke C, and take the number of elements of the C element as denominator. Then you will be able to calculate. Domain is sample space. Number of elements of sample space is reduced to number of event which has already occurred. Clear? I hope from 3 examples on conditional probability you have got some idea about the conditional probability. It is not very tough. If you understand step by step, it would be very easy for you. I have completed only given 3 examples. In part 3 video, I will give you some tricky, standard, good problems on conditional probability. Then your idea would be clear, more clear. If you like the video, please share the video to your friends, students, relatives, so that my purpose or my hard labor, the objective behind my hard labor is fulfilled. Thank you for watching my video. One thing you must know, you must learn part 1, part 2, part 3 and part 4 video. Then you will be able to learn everything about the conditional probability. Thank you very much for watching my video.